All right, welcome everybody. Happy holidays, Merry Christmas, Feliz Navidad, and anything else you celebrate. Welcome. Happy to have everybody here. My name is Cameron. I'm the content lead at Tinybird, and I've got Jim here as well. We're going to try to make this fun, festive. You can see I'm actually wearing this is a penguin sweater, which is
Very nice.
when you work at Tinybird that to have a tacky Christmas penguin sweater. Um, but we've got a lot planned today, so we're gonna jump into this pretty quickly. If you have questions while we're doing this, feel free to ask them in the YouTube chat. We did get notified last week that you do have to have a YouTube channel to ask questions in the YouTube chat, which is a little strange, but a limitation nonetheless. So if you don't have a YouTube channel, you don't want to set one up, feel free to ask questions in our Slack community. I've just shared a link where you can join that Slack community. Won't necessarily be monitoring that during this live stream, but if you do have questions, you can ask them there and somebody will get to them eventually, usually pretty quickly, actually. And yeah. And then, of course, questions, ask them as you have them. We can answer them, as we have time or at the end. I mean, then the final thing too is if you stick around for the end, I'll have a little gift for you. So, so hopefully you can stick around and hear us out. So with that, let's jump in.
Let's build a Santa tracker.
Let's build a Santa tracker. So today, here, let me change this. All right. So what we're actually going to build today, what do we mean by real-time Santa tracker? What we're going to do is build an app for Santa Claus. And the goal is really to help him process this real-time information about his location and the children that are nearest to him in the world, while also managing his inventory. And so we're going to kind of suspend some disbelief here. And what you don't realize is that Santa Claus doesn't actually load up his sleigh with all of the toys and goodies on his way. He actually has to make pit stops in the night. And so we're going to be monitoring the inventory that Santa has on his sleigh with a change data capture stream, and giving him the heads up on when he needs to restock and making sure that the children he's delivering to, he has toys for them. And then the stack we're going to use for this, we're going to use Confluent for streaming those change data capture streams. Confluent is just a really excellent data streaming platform. It abstracts a lot of the complexities of Kafka. You don't have to worry about setting anything up, setting up infrastructure. You can just kind of create a cluster and go. We're going to use Amazon S3 for kind of the almost like a data lake or a file storage system. And we'll integrate that with Tinybird. And Tinybird is going to be our real-time analytics platform. We'll show you how we're going to build this tracker and the APIs for it. And then we'll use Retool kind of for our front end app dev. And so, here you can see kind of this is what the basic structure is going to look like. So everything's really going to be coming into Tinybird. We're going to connect Confluent to Tinybird with our Confluent connector. We have already connected. I'll show you the S3 bucket, and then you can kind of see what this S3 data source in Tinybird looks like using the S3 connector. We've uploaded a small CSV file with some dimensions about the toys that Santa is delivering. And then in Retool, we're building the Santa app. And actually, that app is going to be passing Santa's real-time GPS back to Tinybird to be able to do some of these calculations. And so this is kind of a fun problem. It's obviously really festive, but this is a relatively complex kind of geospatial problem. We're going to have to do some fun kind of database indexing and sorting, some optimizations there. There's obviously an inventory management component here and a logistics component. We only have an hour, so we're not going to get too deep into all of this, but I think we'll demonstrate some of the fun stuff. And as we jump in, so last week I did a live coding session with my buddy Alistair over here at Tinybird, and we had roles. So Alistair was the data engineer, and I was kind of the full stack dev. Now we're going to switch that up this time. So I'm going to kind of play the role of data engineer. And so what I'll be doing is kind of setting up the data pipelines in Tinybird for Jim, and then creating, data sources and data sets that Jim can use to build APIs and integrate those into the front end in Retool. So Jim's kind of the full stack dev here. and I'm kind of the data engineer, which I'm not a data engineer. I've hacked around in Postgres, but that's some of the magic of Tinybird is you can do a lot with a little. So we're going to start in the Tinybird UI here. And let me see if I can, let's make this a little, well, we'll go here. If you can't read my code, let me know in the chat, and I'll try to zoom in as much as I can. But I just want to explain a couple of these data sources real quick. So first, you can see here, this is the children data source. And this has 50 million rows. So actually, if I have this S3 bucket, you can see here, and it's got 50 files of just kind of information about children. And I've connected those to Tinybird with Tinybird's S3 connector. I've gone ahead and done that. So I've got about 3 gigabytes, 50 million rows of child data. We've got first name, last name, the child's location, and then their status. Are they naughty, nice? And then kind of what toy are they getting? And then if they are naughty, some reason for why they're naughty. And then we also have this toys dimension, and all this is just a name for the toy ID. So we'll kind of use this to hydrate some of the front end as we're building. You can see there are 106 total possible toys that Santa can deliver. And each child has an assigned toy ID. And so the other thing you're going to see here is this is kind of a basic framework for the app that we're building in Retool. And I'm going to pass this over to Jim in a second. But what you can see here up here in the left is kind of, we've got Santa's location. And actually we have this little ticker here so we can move Santa along the map. And so what this will do is it's actually going to pass Santa's GPS coordinates to Tinybird to do some processing. So Santa started in the Northeast United States, and he's kind of make his way across Canada and the US. And then down here, we're going to end up populating some information about the nearest child, the toy that they get, things like that. And then over here on the right, we'll have a bar graph that shows us. Thank you, Alistair. I really like this app. I hope you enjoy it. Yeah, over here, we're going to populate a bar graph with Santa's inventory. And we'll be kind of tracking that in real time as well, and restocking Santa as he needs that. So the first thing that we need to do is create an API that is going to show Santa where the nearest children are to help him make the best delivery. So we're not doing kind of a traveling salesman problem. We're just going to say, hey, Santa, here's the closest kid, go make a delivery. And so I'm going to hand this over to Jim, and he is going to create our first Tinybird API, which finds the nearest children next to Santa, and then we'll integrate this with the Retool app.
All right.
Handing it over to you.
Okay, cool. And first, I don't have a crazy sweater, but I'm lucky that Tinybird has these Christmas green t-shirts with complete with a Christmas tree pendant. So adding my holiday bling. Okay, so now we're in the Tinybird UI, and I'm going to create a pipe. And as Cameron suggested, this one, we're going to use this to calculate and find the nearest child. So I'm going to name the pipe that nearest children.
And while Jim, you're doing this, just a quick explanation of what pipes are in Tinybird. Tinybird pipes are essentially the SQL interface. This is how you write SQL queries and create real-time transformations. And they're nice because you can kind of break them up into different nodes and kind of compose those nodes at the end. Tinybird will kind of handle all of that logic, but it's a kind of a nice little development environment for SQL.
Yeah, it's great for when you have a kind of complex query you want to build. You can do it piece by piece and have these nodes work together as you pipe the data through these. I'm going to name this endpoint. In this case, it's just sort of a convention. I'm just going to have one node in this pipe. I'll just call it endpoint. And one nice thing I love about the UI here is when you have a data source that you're going to pull from, you can just click on it and see the schema here. But from the children data source, we want to pull things like we need the child ID. We need the latitude of where that location is, where that child lives. We need the longitude. And then what we're doing here is here, I'm going to close this so we can see this better. Tinybird is built on top of ClickHouse, essentially. And what that brings to the table is a full suite of kind of superpowered SQL, including some geo based functions, including geo distance. So here, and I'm also here, I'm using our templating language to incorporate query parameters into this endpoint that we're building. So here we would pass in where Santa is right now, the longitude, his latitude, and then we're going to compare it with the lat longs of all the children and then come up with a distance. This distance will be in meters. And one nice thing, I don't know, if you're into geo functions, one cool thing about this is it actually does take into account the curvature of the Earth, which if you're doing large distances, that is a very handy thing to have done for you. We're going to order these by distance. And we're going to do it in ascending order. And for now, we're just going to pull in the 50 closest children each time we make this call. So I'm going to run this just to make sure I didn't fat finger anything. First thing you notice, that took a little while to run. And one thing to note here is that when that ran, it processed 2.6 gigs of data. Now, we will address this in subsequent steps, but when you're building these nodes, it's important to keep an eye on things like that. And there's many methods and ways with Tinybird to make that more efficient, which we'll talk about. So now I'm going to publish this as an endpoint. And this is one of the magic things about Tinybird is just by clicking that button, I now have a fully functional endpoint called nearest children. And here's the data. So this pulled in. Here you can see all the different results for each child. Some of these are like this one's 5,700 meters away from Santa right now. So we're going to now switch over to Retool, and we're going to incorporate this endpoint into this front end. So I'm going to come in here.
Hey, Jim, do you think you could zoom in just a little bit on Retool?
Yeah, let me do that.
Yeah, that's good.
Okay. So I'm going to come in here. I'm going to add a resource query. And in this case, there's a lot of different options here, but we're building RESTful APIs in Tinybird. And I'm going to go back and grab the example usage for this endpoint I just created. I'm going to dump that in here. So this is all well and good, but we want to make these dynamic. So I'm going to do a little updates here. Here we have the latitude. Instead of hard coding that, of course, we're going to be passing in something. And then I'm going to do the same with the longitude.
So those values that Jim is passing are actually generated by this app. So you can imagine, Santa's looking at this on his iPhone. It's generating that GPS locally and then sending it to Tinybird.
A couple other things I want to do here. I want to go to the advanced tab, and we're going to run this every 2.5 seconds. That's 2,500 milliseconds. And we want to disable the query. We have a widget on this front end about moving Santa, and when that is not set to move, we don't need the query. But as soon as we toggle the button to move Santa, these queries will start firing. Another thing we need to do is over here on the map, we need to set the points that, this is when it makes the query, it returns the data set. And I'm going to update this to pull those.
I think you just need to run
I also need to name this thing.
Yep.
That would help. Nearest children. And when you're doing this, you can preview things. And here you see down here below, I got I got results back, so we know that's good. I'm going to save and run it. All right, so that's all saved. And
Jim, you might want to change that delay between runs to 2500 too. I know we had some
oh, that's right. That's
trouble
right.
with that, trying
So
to fire the API too much.
let's do that. Reinsave. Okay. So here we go. All right. So I'm gonna
Jim, if you don't mind, I'm gonna show kind of the public version of or the not the public, but
the shared
the kind of the clean version.
Okay. No, that's good. That's a good idea.
Let's refresh this, and then so you can see as we move Santa, it is going to kind of be finding these nearest children. Of course, there's a problem here, which is that as Jim shared, this API takes too long to run because it's not very performant. And so you can see we're kind of only getting sparse results because that API, we're trying to refresh it every 2.5 seconds, but it takes like 3 to 4 seconds to run.
Right.
And so what I'm going to do is explain why that's happening first and then optimize it. So let's hop back over to Tinybird here. And let me refresh so I can see the pipe that Jim has built here. So we're querying this children data source, and you can see we've got this warning from Tinybird. It's saying, hey, you're doing a full scan of this table. And in Tinybird, the way that these the data sources are stored in a columnar format, and they're sort of sorted by a sorting key. And if we go here and look at the schema of this data source, we see the primary sorting key is child ID. And so we're not doing it. We're not filtering anything here. Every time we run this API, we're scanning 3 gigabytes. This is a very expensive query, and so what we're going to do is we're going to use kind of some ClickHouse geospatial magic to optimize this. And so what I'm going to do is kind of do so I'm going to create a new pipe, and we're ultimately going to create a new data source that we can query here. But first, what I'm going to do is I'm going to create a geohash. And so a geohash is something that's actually supported in ClickHouse, where we can calculate a geohash for a lat long pair. And what that will do is basically bucket all of our children into kind of little polygons on a map, and then we can sort of index by that or sort by that, and that'll make this more performant. So I'm going to create this pipe, and it's going to be called geohash children. And so what I'm going to do is I'm going to get my child ID type. I'm going to go ahead and pass the toy ID as well, latitude, longitude. So that's kind of all the information that I want to get from this API. And then I'm going to use this other kind of fun ClickHouse function, which is geohash encode. And so I can pass a longitude and a latitude, and then kind of a granularity level. And I'm going to call this geohash. And what this will do is it's going to, for every child, it's going to get that information, and then it's going to calculate this kind of 4-character geohash. And that's going to serve us really well here in a second. And now what I'm going to do is I want to turn this into a data source that I can query. Now, in Tinybird, you can query. If I had published this as an API, I could query it, but that's not going to solve our problem because we're still having to full scan this data source. So what I want to do is create a new data source. And for that, I'm going to use a copy pipe. And so what a copy does is it basically takes the results of a pipe and it copies them into a new data source. It's similar to a materialized view in that it creates a new data source, but it's not using any of the materialization stuff that ClickHouse supports. It's really just taking the results from a pipe and copying them into a data source. And in this case, you can set a frequency in which you want this job to run. I'm just going to do it once because my data source isn't updating. And so you can see, I've got this preview of data. I'm going to click next. I'm going to create a new data source, and I'm going to call this data source geohashed children. And what I'm going to do is instead of setting the sorting key to be by this child ID, I'm going to sort by the geohash. And that's going to help us here in a second. So I'm going to run this on-demand copy. And what this is going to do, it's going to take all those 50 million results from that job, and it's going to copy them into a new data source called geohash children. This will take a little bit of time to run, and I'm just going to keep an eye on it. But while I do that, I'm going to while it's copying, I'm going to come back to this API, and we're gonna add a node. And what this node is going to do is it's going to filter. So what we're gonna do is we're gonna select star from geohash children, and then what we actually we'll limit this here. We'll do child ID, toy ID, latitude, longitude, and then so we get that from this geohash children. And then what we're going to do is we're going to filter. And so we're going to say we want to do this where their geohash matches Santa's geohash. And so I'm going to use that same geohash encode function. I'm going to pass, let's see, float 32. I'm going to pass Santa's longitude and his latitude. And then I'm going to kind of specify that same granularity. And so what this is doing is it's going to, since this data source is sorted by geohash, and the way that kind of this columnar data store works is that it's going to only process the data where the geohashes match. Oh, if I spelled it right.
Yeah, I was going to say.
Thank you. So you can see here, okay, when I ran this query, I only processed, as opposed to 3 gigabytes, we're processing 1.4 megs, about 25,000 rows. And I'm actually going to
better.
Yeah, much better. So I'm going to drag this up to this node up in front of endpoint. I'm going to call it filter children. So we're just kind of doing some pre-filtering here. And then down here, instead of selecting from children, we're going to select from filter children. Run that. Full scan is gone. Now we're running this in 6 milliseconds instead of, whatever it was, 4 seconds.
4 seconds.
And we've all we've done is change the code. The API kind of remains the same. So if I switch back over to this app, we can see that it's much more performant now. And I'm actually curious, Jim, is this what's going on here? I'm surprised that it's not returning 50.
Because that was the limit.
Do we have the right token here?
Yeah, it's the one I grabbed from.
Yeah, I guess you just pasted that.
Yeah.
Okay. I would expect it to return 50. Let's see. Let's head back over to Tinybird and we'll just try this again.
The joys of live coding.
Santa lawn. Oh my goodness. My fingers are cold. Value, pass those in. Same thing here. Santa lat. So again, we're just passing these parameters. Okay. What is going on? What did I do? No results returned. Template. What did I name these? Did I name these wrong? Let's go look my API. This is what happens in live coding, right?
Right.
Oh, Santa long. That's my bad.
Okay. Yeah.
This should be Santa long.
Details.
Yep. I added accidentally added a new query. Okay, there we go. So we go back over to retool.
And of course, you got it? Oh, yeah.
I think we got it now.
Another potential gotcha with all these geo.
There we go.
All right.
Okay, now we're seeing 50 kids every time it updates. So what we also want to do is kind of hydrate the information for the nearest child. So Jim, I don't know if you've been able to work on that.
I will build that pipe right now. This one's a pretty easy one. And that's another potential gotcha every time you're working with geo functions is the order of lat long. I'd say like 90% of the world uses that order, latitude, longitude, but many use longitude, latitude. And of course, it'll make a huge difference in what you expect. So I'm going to build a new pipe here called child info. And I again, here we're going to change the data source that we're pulling from. We're going to go back to that children data source.
And Jim, I'm gonna answer some questions while you go ahead and build out this pipe, and then when
nice.
you're done building it, you can kind of explain it. But there are some questions about the geohash, which one question was, doesn't filtering by the geohash mean that we're getting the 50 closest children in Santa's geohash and not the 50 closest overall? The answer is yes. And so what we're doing is we're basically pre-filtering because we're assuming that there are at least 50 children in that geohash. And it's kind of this trade-off here. So if you notice, when I added that granularity in the geohashing code, I used a granularity of 4. And that number ranges from 1 to 12. 1 being the largest geohash area and 12 being the smallest. And so what we could have put a 1 in there and kind of expanded our geohash, or put a 12 and limited it. But that is a good point. It's possible that Santa's in a geohash where no kids are close, and that would maybe be something we'd have to deal with in in a subsequent optimization. But we're doing that pre-filtering because we're assuming there are some children within Santa's geohash. And then the second question was kind of, with this geohash approach, the nearest range can't be dynamic. And that is true because we are using a copy pipe. So we're sort of hard coding that geohash size into that copy pipe. Now, in theory, what you could do is create 12 different geohash columns, but then you'd have maybe a filtering problem. I don't know. That's a tough optimization. We're not going to get into that here, but yes, that would be hard coded. But I could see a scenario in which you could make it dynamic and still have performance optimization. But I don't think we're going to have time for that today.
All
okay,
right.
back to you, Jim.
All right. So I just built this real simple pipe called child info. It's just pulling in metadata for the children, mainly for display purposes. But one of the key things here is we're doing a join between the children data source and the toys data source. And that illustrates one of the great things about TinyBird is it's really an amazing way to join your data, to bring data in from different sources, to enrich your streams with metadata, with dimensional data. And here's an example of that. So I'm going to create this endpoint again.
And while you're doing that, I'm just going to, you'll notice we were filtering by child ID there. And yes, we are scanning that, or we're using that 50 million row table. But because we're filtering by child ID, which is the primary sorting key of that table, we're only going to be processing one row for that. So it's very efficient, even though that data source is very large. And because we're using ClickHouse, that's a very efficient query with that filter.
Right. So now I'm back in Retool. I'm setting up the connection to this endpoint we just created. It's going to be child info. Again, we added a RESTful API. I'm going to copy in my example usage, which again, that was just grabbed here from the TinyBird UI. And I'm going to preview this. And it should bring back, yes. The only thing we're going to do here, though, is we're going to change this up. We're not going to hard code it again, of course. And here, what we're doing here is we're basically navigating into the payload that API endpoint returns. And then let me start moving Santa. It's giving me a, oh, don't want that.
You got to save it too.
Oh, yeah, that would help. All right, so we have, and again, why is this not? Let's go to advanced. No, we don't want to delay there.
I think we probably should delay it anyway, just so it as the job. But I guess it shouldn't really matter. But
I'll do it at 2 seconds.
Is it actually returning data? Are you getting?
Yeah, let me stop moving that. Yeah, it is.
Okay. Let's see if it, sometimes retool does not update the, I'm curious if it works on the live app. We were having some retool problems as we ran this yesterday. At least I think they were retool problems. Could just be that we didn't properly sacrifice to the live stream gods as well.
And certainly the problem can't be us. So
Never.
I mean, the endpoint's returning data, so we got that going for us. I don't know if you want to refresh on your side.
Yeah, what I'm trying to figure out is why this map isn't populating, and because it should be.
Yeah.
Let me see. I'm gonna come over here. Child info. It's called child info. Okay. This is odd. That is working. There it is. There it goes.
What'd you
Worked
do?
on my end at least. I wonder if it has anything to do with the fact that we're both trying to use retool at the same time.
Yeah. I was gonna say, show your side then if it's working.
Well, it was working in the editor.
Okay.
Well,
that's promising. See.
I got it. Well, yeah, I'm really not sure why.
Maybe it'll self-heal, and we should get into the setting up the convoluent stream of.
Yeah, let's go ahead and jump into that. It looks like part of the challenge is that the nearest children API is only returning a limited amount of data, and I'm not sure why. Because I think everything is good in there. Okay, well, we'll come back to that because I think we got to keep moving here. Okay, so one of the things we talked about here at the beginning was we were also going to kind of monitor Santa's inventory, right? And make sure that he has enough inventory. So I've actually got a, let me, I need to sign into Confluent, got kicked out. Let me share my screen here in a second. I'm going to show you just this Confluent topic that I have set up. Once I get there. Okay, let's look at our topics. So I've got this Santa CDC topic, and what I actually am, what we're doing is we're kind of tracking, Santa's inventory, and we're kind of, as that inventory changes, I've got a little Python script that's kind of changing Santa's inventory, and it's sending us messages, and you can kind of look at the topic here. Let's start sending some data here. And we should see some messages start to show up. And what you'll see is we've got a toy ID, a timestamp, and then kind of an inventory count. And so what this is showing us is basically, hey, here's how much inventory that Santa has on his sleigh. And the problem, of course, is that, this is not deduplicated data, but we'll get to that here in a second. And so I'm going to go back to Tinybird, and we're gonna connect to this Confluent topic. So we're going to create a new data source. We're going to use this Confluent connector, and I've actually already got the connection to my server set up. So it's really as simple as putting the Bootstrap server in, key, and a secret. And so I'm going to click next, and it'll pop up the topics that I have on that cluster. In this case, I'm going to use this Santa inventory CDC topic. I'm going to get all of the records. I don't necessarily need that, but you can actually select earliest to latest. So just for kind of completeness, I'm going to get all the records on that topic. And so here we go. We're kind of pulling in this data. Tinybird, of course, one of the things it does is it will look at the data types and actually infer the schema. You can modify it if you need to, but everything looks good from my end. And I'm going to call this Santa inventory CDC and create this data source. And so what this is going to do is it's going to kind of pull in all these inventory events as they're streaming. So we're getting updated inventory from Santa's sleigh every second, really. And so, Jim, do you want to go ahead and create an API to kind of get Santa's current inventory based on this stream?
And I will add my version of Retool is working just fine right now. It like self-healed. We're getting the display.
Right.
So I don't know what was going on, but it wasn't us. So yeah, I'll add a pipe while you're talking through that.
Okay, cool. Yeah. Yeah. So basically, what Jim is going to do is because we are getting this stream of change data events, we've got many different entries for each toy ID, and what we want to do is actually deduplicate this so that we have the latest inventory for each toy. And so you can see in this Santa inventory CDC, because I was taking all of the data from the topic at about 172,000 rows. This deduplication problem, in ClickHouse 172,000 rows, that's not going to be a huge pain, and you'll see in kind of as Jim builds this pipe and we get the performance from it, you'll see that this isn't a huge problem. But just imagine this is kind of the real world where Santa has to deliver something like 8 billion toys, because grown-ups get toys too, or Cole, whatever he's delivering. This data source is going to grow to a really big scale. We're going to probably end up with about 8 billion rows. And so what we're going to eventually need to do is kind of create a deduplicated data source. And we'd probably want to put a time to live on this data source as well, so it doesn't grow like crazy. But I'm going to show you that here in a second. So Jim's created this pipe. You want to explain what you've done there?
Yeah. Here we're selected from that CDC inventory table, and we only want the most recent entry for each toy, because there's going to be multiple entries in that table for each toy. Or this is sort of a way to dedupe those results. We're limiting. We just want one result per toy ID. So I got this first stream. You can see what it returns. Just that. The toy ID, the timestamp, and the current inventory. And then I'm going to build another node down here. This one I will call endpoint, because this will be what we end up basing our API on. So let me get this one going. So we're going to select toy name, everything from that current inventory node up above, dot star. And then here we're going to need to do a join, because again, we're bringing in a toy name from the toy table. So we're going to do a join on toys, again, using the toy ID. That's like the unifying attribute in both tables. And we're going to order by the inventory number. And we want ascending value here. So boom. Okay, that ran. I actually typed everything correctly. And again, the magic of Tinybird. Let's create and deploy API endpoint. And we're going to pick that last node. And there we go.
So Jim, while you are taking that endpoint and putting it in Retool, because I think everybody's kind of seen how that works.
Yeah.
You may have seen there that I'll bring it over to my screen. If we go look at that current inventory pipe, you can see that it's processing again. It's processing that whole table, that whole Santa inventory CDC table, as I mentioned. And so what we're going to do is we're going to deduplicate this using a materialized view. And so what I'm going to do is I'm going to create a new pipe, and I'm going to call this Materialize Santa inventory. And I'm just going to copy that deduplication that Jim did. And now what I'm going to do is I'm actually going to create a a materialized view here. And so what a materialized view is in Tinybird is it's a data source that updates incrementally as new data streams in. So the pipe is going to be kind of handling these transformations, and the materialized view will continually update as new data streams in, and it's going to store these transformations and update them as we get new data. So if you're familiar with materialized views from other kind of database engines, you might understand that they need to be sort of manually triggered to update. But in Tinybird, they update as new data is ingested. And so I'm going to call this Santa inventory MV. And we're going to do something here for our deduplication, which is that instead of using kind of the quote unquote standard merge tree, we're going to use a replacing merge tree engine in this materialized view, which is going to help us deduplicate. And so what the replacing merge tree does is if we sort it by toy ID, then we can actually add an engine version, and we're going to call that timestamp. And so what this is going to do is in the background, it's going to kind of find the latest timestamp for each toy ID, and it's going to pull that data in. So we're going to get all of that data into this materialized view, and we're going to create it. And let's go look at this new data source that we just built. And so you'll see as it's kind of populating here, you can see, okay, so we've got 291 rows because it's basically bringing in this data, and it will eventually collapse that into 106 rows, which is how many toys we actually have. But this merge process happens in the background. It doesn't happen all the time. And so what we're actually going to need to do is do a final deduplication in the query. So all we have to do is actually go back to this Santa current inventory pipe, and instead of pulling from the raw data source, we're just going to pull from the materialized view, continue to do that final deduplication in the query. But what you'll see here is take a look at these rows. Right now I'm asking for 175,000. And now I'm only scanning, 107. And this will fluctuate between, 100 to a few hundred as new data streams in. But because ClickHouse continues to merge, because Tinybird using ClickHouse continues to merge those results into the materialized view, we're scanning much fewer rows, maybe only a few hundred, as opposed to hundreds of thousands up to billions. And so now we have kind of this optimized inventory endpoint. So Jim, have you been able to slap that into Retool? Cool.
Yeah, we have the new Santa inventory endpoint now inside Retool. Yeah.
Cool. Do you want to show that bar graph? See how we're kind of getting that inventory?
Yeah. Let me. Well, I don't see it updating, so I wonder what's going on there.
You might have to go to the bar graph inspector and just sometimes if you pull that, well, I think it should be fine.
Yeah, it looks good.
Got the Santa inventory.
Huh.
Let me see what. So this was happening with Retool yesterday.
Yeah.
It would not want to update when.
Why don't we both refresh, see which instance starts looking right?
Yeah.
And
Okay.
So
it looks good on my end, so you can actually see. Here's this.
Oh, nice.
Here's this bar chart. And if we kind of do that move Santa, we'll see. Do we set this inventory to run every 25 seconds or 2.5? Yeah, let's do this real quick.
Yeah.
So I'm just going to set this to update on that same
interval.
Query interval. So again, this is hitting those Tinybird APIs every time this map updates, that Santa's inventory is updating as well. And so in a little bit, I can actually change the speed at which his inventory depletes, as you'll see this in the app. Okay, so we've got a little bit more time, and so you can kind of see we have this basic app that's hitting these Tinybird APIs every 2.5 seconds to show Santa based on your location. Here are the 50 nearest children. Here's the information for the nearest child, name, their status, the toy they get, and then we have this inventory. And now really the final thing that we want to do is, instead of showing all the children, we only want to show the children that for whom Santa has a toy on his sleigh. And so we're going to come back to this nearest children API, and I'm just going to add a node real quick to get Santa's inventory. So we're going to select star from Santa current inventory.
And this is a cool example of where you don't have to always pull from a data source. In this case, we're pulling from another pipe.
Yep. Yeah, we're pulling from this. And we actually showed this in the last live stream we did. It's like you can reuse code in this way. Like if you don't want to have to copy and paste a node from every pipe, you can kind of create an API and then reuse it. And I'm going to call this Santa inventory. And I'm going to drag it up here before the endpoint. And now what I want to do is, well, actually, I mean, I guess, yeah, I'll do it here. It's fine. In theory, I would filter before, but we'll just do this here. And I'm going to join, let's see, I feel like we need a toy ID here too. It's because I'm going to join by toy ID. And so what I'm going to do here is now join this Santa inventory node using that same toy ID. And actually, I'm going to inner join because I only want to return children when we have a toy that's in Santa's inventory. And so again, that kind of automatically updated this API. And so now I'm going to speed up the rate at which Santa's inventory diminishes. And what we'll see is that as this happens, the number of children available is going to start to shrink, right? Because Santa will have fewer and fewer toys on his sleigh until we'll eventually get to a point where, Santa's got to go restock and stop at one of the 50 workshops that are sort of underground workshops in various cities around the world. And then we'll restock Santa and we'll hopefully, see all these children come back. Now I want to make sure that I actually, while this is happening, I want to make sure that I actually publish this. Right? Okay. Yeah, I did.
Yeah. It looks good.
Okay. Yeah. Okay. So here you go. Now the number of children is massively diminishing because Santa doesn't have any toys left on his
that's amazing
sleigh. And actually I have a little function here that can actually cause Santa to drop all of his inventory. And we should see, okay, Santa's out of inventory. We're not seeing any children anymore. So let's send Santa to restock. I'm going to kind of run that script on my end, and boom, Santa, we'll see this inventory restock, and there you go. Now, and apparently there are children in the middle of Lake Superior.
They're good swimmers.
They're on a houseboat or something.
Yeah, there you go. I like that.
Yeah. Okay. So that's kind of the basics. I know we had kind of a few front end challenges here, but I think the front end is probably the least important part of this. I think the important thing, to kind of keep in mind as we look at this is that, we're able to solve this pretty challenging real-time problem at scale. In our case, the main scale problem we're dealing with is we have this 50 million row, child data source. In the real world, maybe that's an 8 billion row data source that becomes much more challenging, but that's a scale that Tinybird really handles well.
Yeah.
And we were able to use these optimization techniques to allow it to handle that scale. So any other questions, Jim? You want to add something?
Well, I was just to say another important thing about this is it's made me even more of a true believer. I mean, the fact that I can now see how Santa could manage this problem. I don't know how he did it when I was a kid without Tinybird, but it's good to see.
Yeah, exactly. Okay, so for those of you who have stuck around, if you do have questions, feel free to ask them. But I also just wanted to just kind of on behalf of Tiny Bird, this is our last live coding session of the year. I know we're kind of, a lot of us are heading into the holidays, but you scan this QR code, you can grab $20 worth of Tiny Bird merch off of our little online shop. You'll see a code for that. If you do have any problems with that, just find us in the Slack community or email us at hi@tinybird.co and we can take care of you. But just want to thank everybody for joining us, and have a happy holidays. It looks like there's no more questions. So
all right. Yeah, thanks everybody for showing up and attending.
Yeah, we'll see you next year.
All right. Happy holidays.
Bye, everybody.